Sorry. Yeah, so we were discussing that RIP, if I have, it will take this one hop away and not these two hops. Shortest path he will follow, right? But what if RIP does not understand the link speed? Then what is the use of, using RIP? So instead of using RIP, we can use another routing protocol. That other routing protocol is your OSPF. This is open shortest path first. And this is a link state routing protocol. This routing protocol knows the link's bandwidth, you can say. The metric is called cost. The metric in RIP is called hop counts, right? In here it is called cost. And the cost of your links is described like this. So if you are using a gigabit link, the cost will be this. If you are using a 10 gigabit link, the cost will be this. Okay.
It will not count the hop, right?
Yes.
It will not count the hop.
No, this does not count the hop. This knows, okay, so if I use OSPF over here, if I use RIP, it will take this path because less hops. But if I use OSPF, it is more intelligent. He knows even though I have to cross two routers, but my data will reach fast if I go via this way. Right? Now, OSPF works in the basis of areas. Means if I say you have a single area, for example, routers, this is in the form of areas and you will have routers over here. A router like this, if you have a few routers, then you will say, okay, this is how my routers are connected, and this has some concept called areas, wherein area 0 is known as a backbone area. Now here we enable OSPF on link basis. You will say this link is in OSPF 0, this link is in OSPF 0, right? So if you are designing a network, you have to design it in such a way that you will have an area 0 in the network. If you have only one area and all routers are in one area, no problem. But if you say I have area 1, area 2, area 3, area 4, then you are supposed to take this number into consideration. Okay, so a router, for example, if I take a router over here and I say this router of mine connects to this router over here. So a router that has one interface in area 0 over here and another interface in area 1, for example. This router over here is known as the area border router. ABR. Because it is sitting on the border, right? This guy has one interface in area 0 and one interface in area 1. You can see that. These devices also will be your backbone routers. If you have all interfaces in area 0, then you can say, okay, this is the pure backbone router because it has all the interfaces in area 0. Okay, getting the point? So let us see. What is the administrative distance of RIP? It is 120, isn't it?
Yeah.
What is administrative distance? It is the trustworthiness of a route received by a routing protocol. So if I receive a route, for example, if I say there are two routers over here and they both are running two protocols, you can run as many protocols you want on one router. So here there is a link that is 2222 and this person, for example, this router is advertising this 2.2.2.2 to this router. And there are both routing protocols. Both devices are running RIP and both are running OSPF also. So this guy will choose which routing protocols data. He will choose OSPF. Why? Because the administrative distance of OSPF is less than RIP. So the protocol makers who created these protocols, they told, okay, OSPF is better than RIP. So anytime a route is received by multiple routing protocols, who will be the tiebreaker? The AD will be the tiebreaker, you can see. You can also change the AD. Okay, getting the point? Okay, no problem. Let us see a few more characteristics. OSPF. What is RIP going to do? RIP is going to send out his whole routing table, right? After every 30 seconds. But
Yeah.
OSPF is not like that. OSPF has something called neighbor relationships. So if I say that I have two routers over here, they both will form something called neighborship. And the moment you say run OSPF on this interface, it sends out something called hellos. It is a small packet, you can say, a hello packet that has something inside it. So what there are some characteristics in the hello packet. So these devices will exchange the hello packets. They will check whether they are capable of forming neighborship, and then they will form something called an adjacency. Getting the point?
Yeah.
So if I say I use RIP, what will RIP do? RIP will send out his whole routing table after every 30 seconds. But OSPF is not like that. Initially, they will exchange their whole database. There is a master slave election that will happen, and they will exchange the database. And after the database is exchanged, they will only send hellos. And if there is some link coming up or going down, then the update is triggered. So no need to send out all the routing table updates after every 30 seconds. Better than RIP, right? RIP has a limitation of 15 hop counts away. This does not have a limitation. Now in OSPF, you have something called network types. Assuming that you are using an Ethernet cable. See, you can use an Ethernet cable here also, or if you have a big network, you can use an Ethernet cable and connect your routers to a switch like this also. Anytime you connect an Ethernet cable, you can say there is a network type. Network type is broadcast. So what happens is, if I say I want, this guy has a link over here, this guy has a link that goes down. What will happen is router 3 will send it on the network. This will be received by R1, received by R2, received by R3 and R4. Right? Now what will happen is R1 received it, R1 will inform it to others. R2, R3, R4 and not R3 because R3 was the one who generated it. So again, this guy will also advertise it out. This guy will also advertise it out. This guy will also advertise it out. So this behavior is not good, right? Why? Because everybody in here is advertising this. So what they did was they said on an Ethernet link type, if you are having Ethernet, you will have something called DR, a designated router, and a backup designated router. Backup DR elected. So what happens is there is adjacency of two types. One is neighbors and the other is adjacent neighbor. See, in your neighborhood, you have two types of neighbors, right? One is a neighbor whom you just say hi bye, and one is a neighbor whom you visit on your festival days, right? So here also, neighborship, this guy will maintain neighborship with everybody. He is my neighbor. He is also my neighbor, but he will form the adjacency only with the DR and the BDR, whoever so is elected. And by default, there is a priority on these links that is by default set to 1. If you want this router to be elected as a DR, you can choose any number from 0 to 255. 55. So this time, if you want him to be elected as a DR, you can change his priority to 2 and 3, rest all to 1. But if you use a serial cable, for example, if I say, if you use a serial cable like this, there will be, this is called a point-to-point connection. And on a point-to-point connection, there is no DR, BDR elected. If we are using serial cables, if I say there is an Ethernet cable over here, sorry, give me a second. If I say I am using an Ethernet cable, this looks like a point to point, but this is Ethernet media. On this media, there will be a DR-VDR relation. Getting the point?
Yeah.